So today we are taking a look at some material from Unit 5-6, which is all about equations and algebraic modeling. First thing we want to do some stuff from box A here, where we look at solving equations. It says here by addition and subtraction, but we're also going to be using multiplication and division to solve these equations. So before we get into solving them, what the heck is an equation? Well, at its simplest, an equation is a statement that two expressions are equal. So this thing that we have right here, 5 plus 3 equals 8, is an equation. It's got an equal sign in it, and equations always have two sides to them. Okay? We've got what we call the left side, which is on the left-hand side of the equal sign, and we've got the right-hand side, or the right side, which is obviously on the right side of the equal sign. And when we say that these two expressions are equal, what we're saying is that the left side of this equation is equal to the right side. So if I evaluate everything on the left side, it should be the same as everything on the right side. So for a simple one like this, we can evaluate it pretty quickly. We can say that our left side is equal to 5 plus 3, which is 8. And of course, our right side, we don't have to do any evaluating at all. It already tells us that this is 8. So if our left side is equal to our right side, then we have an equation that is true, or a mathematical statement that is true. And we are happy about that. So we got another example over here. Again, we can divide this into a left side and a right side. Okay. Our left side over here is 4 times 3, which we can evaluate to 12. Our right side is 3 plus 9, which is also 12. And again, we're happy because our left side and our right side are the same. Okay. If you need a paper, they're on the back table right behind Jason over there. Okay. Now, if our equations only had numbers in them, this would be pretty straightforward, right? But equations can also include variables. So here we've got an equation, 2 plus x equals 10. We've got a variable x on the left-hand side of our equation here. So solving an equation means we want to find the value of the variable, or the number that we could put in to this equation for our variable that would make this equation a true statement. We want the left side to equal the right side. So what number would we have to replace x with here if we wanted this thing to be true? Amy? Yeah, and this one is pretty easy. We can just look at this and say that x is going to equal 8. And when we're solving equations, our final answer is always going to be something that looks like this. We've got a variable on one side that is equal to some number on the other side. And this is what we're always trying to get through to when we solve equations, is our variable equals a single number. So we got another one down here, 28 minus x equals 22. Again, this is a pretty simple one. We can look at this one, think a little bit, and figure out what x is going to have to be. And again, we always want to be able to say x equals some number. So what does x have to equal in this one if this is going to be a true mathematical statement here? Amy again. It's got to equal 6, because 28 minus 6 would equal 22. Now I can write it as x equals 6. I could write it as 6 equals x. It doesn't really matter. As long as I've got one letter on one side and one number on the other side, I have solved my equation. And I'm going to do... So, solving equations. Okay, solving equations can be a little bit tricky, but what you want to keep in mind that what you're doing in solving equations is you're aiming to get to that point where you have the variable on one side equal to a number on the other side. So doing that is called isolating the variable. And by isolate, we mean get it all by itself. Get the variable all alone on one side of the equation. And we're going to follow two basic rules here. we are going to get the variable all alone by doing the opposite of the operation that we see being done to the variable and doing the same operation to both sides. So these are like the two cardinal rules of solving equations. Do the opposite of the operation you see, do the same thing to both sides. So let's take a look at a very simple one here. X plus 6 equals 12. I've got my x right here. It's my variable. I want to get that all alone, all by itself on that side of the equation. What I see being done to my x is I'm adding 6 to it, x plus 6. So I want to do the opposite of what I see being done here. What's the opposite of adding 6 to x? Subtracting 6, because addition and subtraction are opposites. So if I've got x plus 6, I want to immediately subtract 6. But if I'm subtracting 6 from the left side of my equation, I also want to subtract 6 from the right-hand side of my equation. Whatever I do to the left side, I want to do to the right side. And then I can simplify this now. I've got a plus 6 and a minus 6. Those are like terms, so I can sort of subtract those, and I'll be left with just the x. And then on the right-hand side, I've got 12 minus 6, so I do that subtraction, and I get x equals 6. And remember, this is what I'm always looking for. X all by itself on one side, and a number on the other side. So let's take a look at the next one here. We've got t minus 10 equals 3. Our variable is t here. What do we see being done to our t on the left-hand side of the equation? What operation do we see? Nicole? We are subtracting 10. So what's the opposite of subtracting 10? Nicole? Adding 10. So we're going to add 10 to both sides. So I take my t minus 10, and I add 10. Then on the other side, I've still got my 3, but I'm going to add 10 over there as well. So I've done the same thing to both sides. And then I can simplify. Minus 10 plus 10, those are going to cancel each other out, because minus 10 plus 10 just gives me 0, so I'm left with just the t on that side. And then 3 plus 10 gives me 13. So t equals 13. And that's what I wanted to get to. T on one side, a number on the other. So our next one here, we've got negative 4 plus y equals 1. Okay. What is on the same side of the equation as our variable? Our variable here is y. We've got a negative 4. Okay, a minus 4. Okay. So what's the opposite of minus 4? What do we think here? Stephanie? Positive 4. So we're going to add a positive 4 to both sides. So I've got my negative 4 plus y. I'm going to add a positive 4 there. If I do that on one side, I got to do the same thing on the other side. Positive 4 there, positive 4 there. So if I've got a negative 4 and a positive 4, they cancel each other out. 1 plus 4 gives me 5. And there we go. I'm exactly where I wanted to be. Okay. Y equals 5. Well, let's take a look at our next one here. We got 3x equals 12. What operation do I see that is being done to my x or my variable this time around? Liam? Multiplication. What am I multiplying it by? Yeah, 3. So what's the opposite of multiplying something by 3? Liam? Division by 3. So I'm going to take both of my sides here, and I'm going to divide them by 3. Okay? I can just write it just like that. So on this side, I got 3x divided by 3. Well, 3 divided by 3 just gives me 1. So it's like these 3's cancel out, and I'm left with the x. On the right-hand side, 12 divided by 3 gives me 4. So again, that's what I wanted to get to. X equals 4. X on one side, 4, a number on the other. Okay, last little example here in this section. I've got 2 equals x divided by negative 4. Okay, so what operation do I see being done to my variable? Sindela. Division by negative 4. So what would be the opposite of dividing by negative 4? What's the opposite of division? Multiplication. So I got to multiply both sides by something. What do I need to multiply both sides by? If I'm dividing by negative 4, I got to multiply by negative 4. So I'm going to multiply by negative 4 and by negative 4. On the left side, I have negative 4 times 2 gives me negative 8. On the right-hand side, I'm going to have negative 4x divided by negative 4. Well, these negative 4s are just going to cancel out. If I multiply by negative 4 and then divide by negative 4, I'm left with just x. So there's my answer. X equals negative 8. Okay. Now, where it gets a little bit tricky is sometimes there is more than one operation that has to be done to get the variable all by itself. Okay. You remember order of operations. Good old BEDMAS, right? When we're solving equations, we follow the same order of operations, but we do it backwards. Okay? We always look to do subtraction or addition before we do multiplication or division. Okay? Again, we're still isolating the variable by doing the opposite of the operation we see, and we're always doing the same operation to both sides. So I don't think you have this example on your page, 3x plus 5 equals 14. So just watch up here while I do this one. Okay? What operations do I see being done to my x? Well, I've got a 3 times the x right there, and I've got a plus 5. Okay, so two operations, multiplication and addition. Okay? I have to do the opposite of both of those operations. Now, which one do I want to do the opposite of first? According to this, I want to do the opposite of my subtraction or my addition first. So let's see, my addition here is plus 5, so I want to subtract 5 from both sides of my equation. So let's write this out. I got 3x plus 5. I'm going to subtract 5. Same thing on the other side. I'm going to subtract 5. Plus 5 and minus 5 cancel out, and so I'm left with 3x equals 9. Now, it should be pretty clear where we're going to go from here. All I see is that multiplication by 3. So what am I going to do to both sides of my equation now? Bam. I'm going to divide both sides by 3. 3 divided by 3 leaves me with 1, so I just have that x. 9 divided by 3 gives me 3. And I am done. Okay, I've got the variable by itself, and I've got just a number on the other side, so x equals 3. All right, so this one you do have on your page here. I think 13 equals 5x minus 7. Okay. Our x is right in here. What operations do we see being done to this x? What's going on that same side of the equation there? Cindella. We see subtraction, and what else do we see? Multiplication. We're multiplying our x by 5, and then we're subtracting 7. So which one am I going to undo first? I'm going to subtract. And how am I going to undo it, Cindella? I'm going to do addition. So I'm going to add 7 to both sides. 13 plus 7, and then 5x minus 7 plus 7. Minus 7 plus 7 cancel each other out, and I'm left with 5x on this side. On the other side, I've got 13 plus 7, which gives me 20. Now I want to undo the operation that I see left here. Okay, so I see 20 equals 5x. How am I going to undo the multiplication that I see here? By? 5. So divide both sides by 5. Those guys cancel, and I'm left with 20 divided by 5 equals 4. So 4 equals x is a good solution there. Okay. I've got the 4 all on one side. I've got the x all by itself on the other side. All right. Let's take a look at this next example here. We've got 9 equals negative 2x minus 7. Okay. How do you think we should start this one? Ezra, what do you think we're going to do first? Okay, so how are we going to undo the subtraction? 2 to both sides. 9 plus 7, negative 2x minus 7, plus 7. What is this going to give me, Nazrat? and just the negative 2x. And then where do I go from here? I got 2x equals 16. I want to get that x all by itself. So what am I going to do here to both sides of my equation? Heather, what do you think? Which by? Not just 2, but negative 2, exactly. If I see negative 2 times x, I got to make sure I divide by negative 2. Okay? And that is one of the more common mistakes people make in solving these equations, is they forget that negative sign. If I do negative 2 divided by negative 2, they're going to cancel out and just leave me with the x. 16 divided by negative 2 is going to give me, what's it going to give me, Heather? Finish this one off. And because it's a positive divided by negative, the answer has to be negative, exactly. So it's a negative 8. Okay. Who wants to walk us through this next one here? Do I have a volunteer? Nicole. Okay. Right. Couldn't have said it better myself. We think of this as a positive 7, so we do the opposite of it. We subtract 7. If we subtract 7 from one side, we subtract 7 from the other side. These guys are going to cancel out. And I get 25 minus 7, which is 18. Stephanie's nodding at me, so it must be right. And then, Nicole, we're back to you. Where do we go from here, Nicole?
Then we have the negative 3x.
Okay. All right, we're dividing both sides by negative 3, because we see negative 3 times x. And what is our final answer going to be here, Nicole? Negative 6. Excellent. Right. And we'll do this one last example here, and then we'll make things a little bit trickier. Okay. So I got negative x plus 7 equals 2. Stephanie, what do you think? Right, we're going to subtract 7 from both sides. 7 minus 7 just leaves us with this negative x. 2 minus 7 leaves us with negative 5. Now this is another place where things get a little bit tricky here. I just see that negative x on the left-hand side. I don't want to just have negative x. Okay? I want to get x all by itself, and it's got a negative sign hanging out with it. It wants to be all alone. So what should we do here, Stephanie? Okay? Or we can think of it as, remember we talked before about if we don't see a coefficient on our on one of our terms, we assume that there is a negative 1 there. So I'm just going to write in that negative 1 like that. Now we can think of this as dividing both sides by the number that is multiplied by the x. Negative 1 times x. So I'm going to divide by negative 1 and negative 1. Cancels, cancels. And then negative 5 divided by negative 1 is going to give me positive 5. Okay. So let's take a look at the back of the page. Things will get a little bit tricky, but nothing you haven't seen before. Okay. What if we have something like these guys where we've got more than one variable term? Okay. This one here, we've got a 7y, we've got a 5y. Okay. Remember, what we're going for is variable on one side, number on the other. So the first step when we're doing these ones is we want to get all of the variables onto the same side. And again, we get them onto the same side using opposite operations. So here I've got a 7y and I've got a 5y. I'm going to deal with this 5y before I do anything else. I want to get it from the right-hand side over to the left-hand side. And the way I can do that is, if this is a positive 5y, I can subtract 5y from both sides. So I got a positive 5y, I'm going to subtract a 5y. But if I subtract 5y from this side, I've got to subtract 5y from this side as well. On the right side, 5y minus 5y cancels out, and we're left with just the 10, just like what we wanted. Over on the left side, 7y minus 5y, because these are like terms, I can collect them together, and I'm going to subtract my coefficients. 7 minus 5 is 2. I'm still going to have a y, and I'm left with 2y equals 10. Now it's just like one of the ones that we were doing before. See multiplication by 2, so I can divide by 2, and I get y equals 5. Okay. Now, the great thing about solving equations is that you can always check your work when you're done at the end. Okay? So you should always know whether you get one of these things right or not. And the way you can do that is by going back to your original equation here and looking at your left side and your right side. So I'm just going to give myself a bit more room here. I think we've got plenty of room on the page. So give yourself some room underneath. And just rewrite the original equation. We've got our left side was 7y, and our right side was 5y plus 10. I've done all this work to figure out that I think y should be equal to 5. What happens when we sub y equals 5 into the left side and the right side of our equation? So let's see, on the left side we get 7 times 5 equals 35. On the right side we get 5 times, let's sub in that y for 5, plus 10. And then we can evaluate this. 5 times 5 is 25. 25 plus 10 is 35. Left side is equal to right side. So we are happy. Okay? We know that we have solved this equation correctly because when we sub those in, we got the same thing on both sides. Okay? So let's do the same thing for the next example here. We'll do our solution, and then we will check it by looking at the left side and the right side. Okay, 5x plus 6x equals negative 9x plus 40. Okay. There's something that we can do with this one even before we start moving terms from one side to the other. On the left side, we got a 5x and a 6x. These are like terms, and what can we do with like terms? We can add them together. So we can take that 5x and that 6x, add them together, and get 11x. And I'm going to keep the right-hand side exactly the same for the time being. Now I look at this, and I see that I've got x's on both sides, so I want to move one of those x terms over to the other side by doing the opposite of what I see. So let's move this negative 9x over to the other side. What is the opposite of negative 9x? What do you think, Emerson? So let's put a positive 9x on both sides. Just like Emerson said. So 11x plus 9x, again, like terms, I can collect them together. 20x, negative 9x and positive 9x cancel each other out, and I'm left with this 40 here. How do I finish this off? Isaac, what do I need to do to both sides here? I see multiplication, so what operation am I going to do? Division. What number am I going to divide both sides by? 20. Right, I see multiplication by 20, so I divide by 20. X equals 2. Okay. And let's check this here. Okay. Let's go back to our original equation here. I'm running out of space here, but I'll just do left side is equal to 5x, so I'm going to put in a 2 where I saw x, because we saw x was 2, plus 6 times 2. Let's see, 5 times 2 is 10, 6 times 2 is 12, so 10 plus 12 is 22. What's our right-hand side here? Well, our right side is, let's go back up here, negative 9x minus 40. So negative 9 times 2 minus 40. Or is it plus 40? Oh, it's plus 40. Sorry. Negative 9 times 2 is negative 18. Negative 18 plus 40 is positive 22. 22 and 22, left side equals right side. Okay, so we are happy. We've done this correctly.